As Americans approaching the new millennium, we want a lot, including powerful, smooth-running vehicles and the freedom to drive them as much as we please. Of course, we also want good, clean air to breathe and long, healthy lives. And those opposing demands are in serious conflict. The many millions of cars on American roads are a major source of our air pollution. Fortunately, a lot of people have been busy improving the efficiency of engine systems and changing the formulation of fuel. Today, we'll focus chiefly on what's been going on with fuel. Hi, I'm Jim Scopolitis. This program will update the one from several years ago called Today's Fuel and its Effects on Drivability. But there's a lot of information here that's still relevant, so remember, it's available. Here's a quick recap of the basic problem. Gasoline is a mix of many different hydrocarbons. Hydrocarbons are grouped in three families, but all consist entirely of hydrogen and carbon atoms. A vehicle on the road produces several types of undesirable tailpipe emissions. Some ordinary hydrocarbons that escaped burning, nitrogen oxides and poisonous carbon monoxide, which are products of combustion, and other problem chemicals, such as benzene, which can cause cancer, and sulfur, which is bad for catalytic converters. Besides these tailpipe emissions, some hydrocarbons evaporate before burning, and, if not captured, will escape from the vehicle. All these emissions can be hazardous to health. Sunlight acts on hydrocarbons and nitrogen oxides to produce low-level ozone, which is a key component in smog. Long ago, the federal government set limits for both carbon monoxide and ozone. And of course, enormous changes have been made to engine and exhaust systems to reduce these emissions. In GM vehicles, the whole intricate PCM engine control system and the catalytic converter do the biggest job of reducing tailpipe emissions, with help from the exhaust gas recirculation system, which cuts down on nitrogen oxides. To reduce vaporization emissions, the positive crankcase ventilation system routes crankcase vapors so they burn instead of escaping to the air. And the evaporative emission control system keeps most gas vapors from the fuel tank from escaping the same way. Beginning with a few 1996 models, the enhanced evaporative emission control system reduces vapor escape even more by putting the PCM in charge of the evap system, with the ability to check it for leaks. Also beginning in 1996, Onboard Diagnostics 2 enables the PCM to discover problems in emission control systems much earlier than before. All of these developments have dramatically reduced emissions. Let's pause for an important point about enhanced evap, which is planned for all 1997 Oldsmobiles. This system turns on the malfunction indicator light if there's any leak in the evap system, which could simply be a gas cap that's not tight. So the owner of a vehicle with enhanced evap that has a lighted MIL may just need to be told to always tighten the gas cap until at least 3 clicks are heard. So much for vehicle emissions control systems. Recently, oil companies have been required to help reduce emissions. For background on the fuel picture, let's review octane and volatility. These are two characteristics of fuel where the needs of an engine and the need for clean air may not work together. Octane is simply the measurement of a fuel's ability to resist engine knock. When a fuel with a low octane rating is compressed, the last unburned vapors of it may ignite spontaneously, causing knock. A fuel with a higher octane rating will withstand more pressure and heat and burn smoothly across the combustion cylinder. But increasing octane can cause other problems. For one thing, as we discussed in that earlier program, some high-octane fuel can cause cool weather start-stall problems in some engines, not because of the octane, but because of lower volatility at certain temperatures. For best results, owners should follow Oldsmobile guidelines for the best octane level for each model. In 1996, the only Oldsmobiles requiring the premium octane level are the LSS with a supercharged engine and the Aurora. The second characteristic of fuel that's key to our story is volatility, a fuel's tendency to vaporize. Liquid gasoline won't burn, so gas needs to be volatile enough to vaporize as it enters the cylinder. Many hydrocarbons in the olefin and paraffin families tend to vaporize readily, and all gasolines need to have enough of these so-called light ends to help engines start easily. But a gasoline containing too many light ends tends to evaporate early, especially in warm weather. So in the summer, highly volatile gas can be a big environmental problem. Now let's see how oil companies have changed fuel itself to reduce both kinds of emissions. In the old days, lead was used to increase octane, but lead's very destructive to catalytic converters. So the first big change in fuel was the move to unleaded gasoline. In 1989, changes in fuel really got rolling when the Environmental Protection Agency, or EPA, established the first volatility standards, setting maximum vapor pressures for fuel. The Clean Air Act amendments of 1990 required many improvements by future dates, including by 1992, the use of oxygenates in fuel during the winter in areas of the country with carbon monoxide problems. The oil industry likes oxygenates because they increase octane, but the EPA likes what they do for emissions. Here's how it works. As we've said, all hydrocarbon molecules contain only hydrogen and carbon. The addition of even a single atom of oxygen, as in this ethanol molecule, makes the substance an oxygenate, which can increase the oxygen in an engine's air-fuel mix. That improves combustion and reduces carbon monoxide emissions in cold weather. In that earlier program on fuel, we explained the pros and cons of the three most common oxygenates and the limits on how much of each may be present in any gasoline. But you should know that in all of our 1996 owner's manuals, GM is recommending against the use of fuels containing any methanol, which can seriously harm fuel system components. In 1992, Phase 2 of the EPA's vapor pressure standards went into effect, lowering volatility limits during the warmer months when vaporization occurs more easily to the ones now in effect. Areas with the highest ozone levels, the so-called non-attainment areas, have even lower hot weather limits. Under the Clean Air Act amendments, detergents were required in all gasolines by January of last year. Detergents minimize engine deposits, which can increase emissions and cause poor drivability. Now, here's the big one. Also by January of 1995, the Clean Air Act amendments required the use of reformulated gasolines, or RFGs, in areas with the most severe ozone problems. Reformulated gasoline is cleaner burning gas, designed to reduce both kinds of emissions by meeting a variety of requirements. It's easy to confuse oxygenated gasoline with reformulated gasoline, especially because RFGs must contain some oxygenates. But the special oxygenate requirement is aimed at reducing wintertime carbon monoxide in areas with the worst carbon monoxide problem, while the RFG requirement is year-round and targets ozone-creating emissions in ozone non-attainment areas. The two lists of areas are not the same. Just how gas is being reformulated is largely decided through an exciting collaboration called the Auto Oil Air Quality Improvement Research Program. For 8 years, the members of the American Automobile Manufacturers Association, or AAMA, that's GM, Ford, and Chrysler, have worked with 14 oil companies in a $40 million study of the interaction of vehicles and fuels. More than 5,000 vehicle tests were involved. The result? is the ongoing development of gasolines that produce fewer tailpipe emissions and evaporate less easily. The new RFGs must meet the EPA's Phase 1 emission standards for fuels, which went into effect in 1995. These standards require that between 1995 and 1999, oil companies produce gasoline which reduces vehicle emissions by 15% compared to a baseline 1990 gasoline. The standards also specify some ways of doing it. Meanwhile, emissions problems caused by vehicles continue to be studied. The EPA now requires that non-attainment areas, either ozone or carbon monoxide, do better testing of exhaust emissions. The standard for this testing is the IM240 program. The name stands for the Inspection and Maintenance Test, 240 seconds long. In this kind of test, which is done on a dynamometer, the technician uses the accelerator and brake to keep the vehicle's trace on the highway of the display. This enables the test to analyze the exhaust not only at idle, but also under simulated highway conditions. In January of 1995, Denver and Phoenix became the first non-attainment areas to use IM240 centralized testing. Others have followed. But the EPA now allows more flexibility in this program, where flexibility is appropriate. For example, in Michigan. An IM240 program was adopted for a section of western Michigan, until a study proved that many of the emissions contributing to its excessive ozone blew across the lake from Milwaukee and Chicago. Repairing all the vehicles in Michigan wouldn't have fixed that. On the other hand, some states, like Ohio, have voluntarily begun IM240 programs. These states figure that better air quality encourages local industries by freeing them from making more improvements than they'd otherwise have to, and that will attract new business. Now back to fuel. Let's wind up our story by seeing what's happening right now and what's coming. And I do mean it's our story. By 1996, GM has become deeply involved in guiding the developments in fuel. For example, GM has recently announced that it doesn't recommend an additive called MMT. MMT, which contains manganese, is an octane enhancer, though not an oxygenate. There's evidence that it can cause a net increase in hydrocarbon emissions, and the EPA opposes it. Still, MMT may be coming soon to gas pumps near you, so you should know about it. Since 1977, MMT has been banned in the United States for use in fuel, but it's been legal in Canada. However, because of problems with it, the Canadian government is currently working to ban it. Meanwhile, last fall, a U.S. appeals court approved its use, and MMT is now a legal fuel additive in most areas of this country, although not in reformulated gasoline. This concerns GM for several reasons. Besides that evidence of increased hydrocarbon emissions, GM vehicles in Canada showed serious spark plug fouling by manganese oxides. In one GM engine family, spark plug warranty was as much as 50 times higher than in the U.S., and misfiring caused a high level of complaints. In other studies, vehicles have also shown more oxygen sensor deterioration and more catalytic converter plugging, again with manganese oxides. These problems may also have impact on our vehicle's emissions compliance and on our extended warranties and extended maintenance intervals. For all these reasons, 1997 GM owners' manuals will advise customers to check for the presence of MMT in the fuel they use. Through 1999, Phase 1 of EPA's emission standards for fuels will continue in effect, requiring that 15% reduction in emissions compared to the base 1990 gas. And RFGs will be how fuel gets there. And just this past June, far and away the country's highest standards in clean-burning fuel were achieved with the statewide adoption of California's own Phase 2 reformulated gasoline. GM technicians who live in California will receive special training on this super high-quality gas, which is expected to reduce problem emissions by 3 million pounds a day. That's the equivalent of taking 3.5 million cars off the road. To accomplish that, oil companies have removed more benzene and sulfur than before and performed extra processing to reduce evaporative emissions. GM has been involved in the very extensive testing of these products and is confident that they won't harm vehicle parts or affect drivability. So the AAMA, GM, Chrysler, and Ford enthusiastically support California Phase 2 gasoline. But some newer gasolines sold outside California, such as those containing MMT, might have negative effects on both engine parts and engine performance. So now there's another challenge to the fuel industry, and this one's from the auto manufacturers themselves. It's the AAMA Gas Specification Program. The auto industry's call to the oil companies to develop special fuels that will meet all EPA regulations while providing optimum engine performance and maximum durability of parts. This specification sets challenging limits on fuel volatility and prohibits the addition of substances like silicon and manganese. The spec also includes drivability standards for gasoline. These gasolines may cost a bit more, but GM wants customers to have a choice that includes fuel designed to say yes indeed to the environment and yes indeed to customer satisfaction. And in the future, for one thing, the EPA is likely to lower the ozone limits, creating more ozone non-attainment areas. And in the year 2000, the EPA's Phase 2 emission standards for fuel will go into effect. These won't be quite so tough as California's Phase 2, but they will call for a 25% reduction in emissions compared to that 1990 gas. And we can expect more changes for fuel and for vehicle systems in the years that follow, because so much is at stake. See you next time.